Hey everybody. So this mini lecture is about other kinds of data. Everything you've watched about from me so thus far has been about vectors. And so now I want to talk about a few items, and you've heard us mention these before. We'll spend a lot more time with some of these. So this is meant to be kind of a quick overview, and we'll gain a little bit of familiarity. Uh, Actually, I guess I should say we're going to spend a lot more time with data frames. We'll spend a little bit of time with the other things. In any case, let's go ahead and dive into it. So we talked about vectors. The next item that's worth knowing about in R are lists. And lists sounds like kind of a generic, vague thing. That's actually true in R as well. Lists are in some ways really powerful because they can essentially like contain bags of everything, all sorts of arbitrary data types. You could make a list and store a bunch of numbers in the first item, and then you could store like a whole page of text in the second item. You can make nested lists where each like the first item in a list could actually be like a huge data frame, and then the second item in the list could be like pages and pages of text again. So again, lists are very flexible in that way, but by the same token, there's not necessarily a lot of, you don't like take a list and add it to something, or you're not like often doing complex operations on a list. Often lists are basically used to store things and return values, and then you like grab things out of it that you need and perform calculations on them. You can see you often the trick to recognizing, oh, I'm dealing with a list in R. You can obviously use things like type and class and things like that. But if you see something and it has this type of output in the console where you see like that double bracket and there's a number, then there's some value and a double bracket and a number and some value, that often means you're dealing with a list. And so what's happening here is it's like the first item in the list and shows you what's in that item. Second item in the list shows you what's in that second item, third item, and so on. Let me show you a second example. So now what I've done is I have the first item in the list is the number 4. The second entry in the list is actually a vector of all the letters in the alphabet. The third item in the list is the word rat, right? You can see how lists get complex very fast. If we save that, we'll just call it my list, and you call class on my list. And indeed, R says, hey, that is a list object. If you ask for the structure, says, hey, this is a list. It's a list that's 3 and it's long. Here's what's in each of those. And here is the different type of item or the data type in this entry. So like the first entry is numeric, the second entry is character strings, and so on. Length also works on my list. So if I call length in this case, it's going to say 3. So that's an important thing to note, right? Because the second item in the list I made actually has 26 letters. It doesn't give you the number plus the 26 letters plus the word rat and say there's 28. It gives you how many like top level items there are. If you wanted to grab that second point in the list and we said length my list and we index that second item, oh, I didn't type length correctly. Now it's going to say 26 because what happened here is we pulled out the vector at the second entry in the list and we said how long is that vector, and it said 26. Okay, that's enough about lists for now, but just to kind of be aware they exist and they're great for storing things. The next item, and we're going to spend a lot more time on this, so this will be a high-level overview, is a data frame. Functionally, I think the easiest way to think about a data frame is it's like taking a vector and sticking it side by side with another vector. So we could just call data.frame in R, and actually let's use the built-in letters object that's part of base R. If you print that out, it's just all the letters. And so if we feed that into a data frame, instead of that vector structure, where if we just print letters in the console, it just returns sort of the items just all the way across. You can see if we put letters into data frame, it now takes on this structure, this column type structure. The column is called letters because that was the name of the object. And then we see how many rows are in the data frame. Let's save that as my data frame. So now let me show you a couple things. If we call length on my data frame, it says length of 1. That's kind of weird. Let's check out a different function. Dim, this is short for dimensions. If we call length on my df, we get 2 dimensions. And so now you can probably get a clue about what length is actually sort of accidentally measuring here, which is that number of columns. What dim shows is we have 26 rows and one column. We can prove that by creating a new version of this, and we'll call it mydf2. We'll just feed in letters again. And if we look at mydf2, it's now just 2 columns. Each is a column of letters. You can see at the top, if you try and run the same thing, R won't let you have a data frame with that has the multiple columns with the same name. And so how it solved that is it disambiguated by saying letters.1. If you were to add letters a third time and run that, it would be letters.1 and letters.2 and so on. If we call dim on the new object, it's going to say 26 rows, 3 columns. That's the basics for a data frame. The other thing to note about a data frame is that you can have different types of columns. So we can have letters and let's just say numbers here. Oh, it didn't like that. No, it didn't do recycling. I was hoping it would do recycling. I guess that's a good thing to note. It won't. R will not let you do recycling in a data frame, but you can feed in a single number and it will recycle that all the way down. So let me show you what I'm talking about here. So in this case, I fed in the 26 letters and then I fed in the number 1 and R said, okay, great. That's a data frame, 2 columns. First column is letters. You didn't give us a name for the second column. We'll just call it X1. And all those values will be 1. We'll recycle it all the way down. If we'd wanted to call it X, we could do letters and then X equals 1. And if R prints that out, it's the first column is going to be letters, the second column is going to be X, and so on. But so you can see in this case, we have in this new my data frame, the first column is a character string, the second column is numeric, and R will tell us about that if we feed that into the structure function and we see the first column is a character column, and then R is going to say, hey, this next column is numeric. Okay, bouncing on. Second, sort of, and these resemble a data frame, but they're more bare bones, are matrices. So matrices have to have all the same type of data in them. You can coerce matrices and data frames back and forth in R. Sometimes you get weird results because, again, data frames are meant to store columns of different types of data. So they're more like a spreadsheet, whereas a matrix is more like a multi-column like set of numbers or a multi-column set of observations. And so generally, if you're like storing different variables all in some sort of like spreadsheet column type structure, you use a data frame. Matrices are more for like math operations, or you're sort of like storing a set of values in a 2-dimensional format, right? So you might have like a distance matrix or something of that fashion. So we can tell R something like matrix. That's not a very fun one. If you open up the matrix function in R, it actually will let you do things like it'll say 10 rows and 10 columns. In this case, I didn't feed in any values, and so it simply printed out a completely like blank, like NA matrix of that is 10 rows and 10 columns. We could put a number in there, number 2. And in this case, because I only gave it one value, every number is going to be 2. We could feed in a larger vector like 2, 3. And in this case, R is going to copy all that stuff until it fills up the matrix. So there's an important function in here. Important option for this function. If you hit comma and keep hitting tab, called the by row function. And what that tells you is, should R start filling these values by row in the matrix, or should it start filling by column? And we're not going to get into that right now, but if you get into, if you're using matrices, that obviously matters a lot, how you're sort of filling across those values. Okay. Last thing we're going to talk about before we get into factors is an array. An array is simply a stack of matrices. And so R has the ability to essentially take like a 3-dimensional data storage. And so if you think about a matrix as row and column, you can stack those on top of each other and you end up with height as well. And so instead of that, you index a matrix using the brackets and one column in between for row and column. So let me show you an example. Let's say matrix. And you open up the bracket, and then you can put a value there or a value on either side of the column to grab rows or columns out. An array is going to have 2 columns because now you have to select the X, the Y, and the Z value. We'll talk about subsetting matrices in arrays at some point, but to briefly show you how this might work, I'm just going to create a matrix here. my matrix. So what I have created is a matrix that is 10 columns long, wide and 10 rows long. And in this case, we just have the way, because of the way it filled, each column is simply the numbers 1 through 10. So if I wanted to select out the first column, rows always come before columns. So I would say open up the brackets and I'd say empty, comma, 1. And now R is returning the first column. If I wanted to return the first two, I could feed in a vector on the backside of that comma, and it's going to give me the first two columns. Conversely, if I put that on the front side of that comma and leave it blank on the backside, it's going to give me the first two rows. You can do both. You could say, give me the entries at the first two columns and the first two rows. In this case, it's going to give you just those 4 items. So an array simply does a more complicated version of that, where you can play in that Z space as well. Okay, last thing we're going to discuss in this video are factors. And factors are sort of held out as special because they are sort of weird and special. I'm going to show you why. So in this case, let's say we have a factor variable. And so we're going to make a vector of sex. In this case, it's going to be male, female, female, male. And then we're going to say, turn that into a factor. So all we've done here is we've nested that vector in the factor function. If we call class on that sex object, R is going to say, hey, this is a factor. But if we say type of, which is a function I don't know if I've talked about in a video, just another way of saying what type of data is this, R is going to say, this is an integer. What's going on there? So essentially, factors are just integers with character labels on them. And so they're not actually character strings. It's more like R secretly has integers under the hood, and it is assigned like titles to those. So that can have some weird behavior. So, oh, that didn't work. Let me show you a different example here. So if we say, actually, you know what? I should come back to this in the video. Let's put a pin in that. I will show you the weird behavior. This order will be better. So we've created this factor. We might want to look at the titles assigned to the integers, or like the characters that are traveling on top of it. So in this case, if we call the levels function and put the factor vector inside of it, it prints out female and male. What that's showing us is that this factor, this vector of factor values has 2 different observed values, female and male. You can also call n levels, and it simply says how many levels there are. If you call factor into the structure function, it's going to say, hey, this is a factor with 2 levels. Here's what those levels are, and then it repeats. Now, here's where we get into that integer thing. Here's the proof of it. R doesn't say, oh, and it actually says male, female, female, male. R says the actual values here are 2, 1, 1, 2, right? Under the hood, it's actually viewing the numbers. In this case, we have like the default was that female was the first level, or the 1, and male was the 2. We can reorder that within that factor call. We can say, here's the levels. In this case, the first level is male, the second level is female. For things like this, it doesn't really matter, right? It's more just R is treating one as the 1 and the other as the 2, and you can flip that order. In this case, we reordered by restarting the factor and saying, hey, male's the first level, female's the second level, and now we see that instead of female, male for the levels, it prints male, female. If we call as character on that, it looks actually the same, right? It prints out a character string. So you might at first think nothing's happening there, but if you run the original sex vector in your console again, you can actually see R seems to be treating those differently, right? Because there's no quotes around those values. Whereas when you call as character string, it gives you those character quotes. It doesn't print out anything about levels. So we know something's going on there. Let me show you where things start to get weird. In this case, we created a factor with years. So we concatenated 1990, 83, 77, and so on, and we called factor on that. So we have this object that is all these years, and we've said each of these years is a level. In this case, 1990 was repeated twice in the vector, right? So we have 4 levels for 5 items. If we call as numeric on that value, it gets us a really, really unwanted result. Because what's happening here is it's giving you like the integer that R is using to represent the factor, or that that factor is sort of standing in for, rather than the actual number. So in this case, if you called as numeric on those factors, odds are you'd actually want 1990 to print out, but R's not going to give you that. R is going to give you the number 3, because it's saying, hey, this is the third integer, or the third factor. R doesn't know these are real numbers. It just knows it's using like an integer format to represent some set of objects. On the other hand, if you call as character on that same factor vector, it's going to return those numbers to a character. And if you feed that into, then if you nest that within the as numeric call, it's going to spit out the actual numbers you want. You can see that because like if you subtract the number, if you subtract the number 1, it's going to give you a number. It's not going to throw some sort of error. So what's going on there is coercion. R takes whatever you feed in, and if you say as this, tries to coerce it to that thing. The simplest behavior, if you feed R a character string, is it takes those quotes off and says, is this thing a number? So if you feed in the character string 1990 and R tries to coerce it to a number, it drops those quotes. It says 1990. That seems like a number. Let's just make it a number. With a factor, it does the same thing, but in this case, it's saying, oh, under the hood of this is the integer 1, so we'll just go with 1, so you get an unwanted result. You can also change the levels of a factor. So you actually do that using indexing. So that levels call returns the 2 factor levels. If you index with the number 1, it returns the first level, and then we can retitle that. In this case, we'll make male all uppercase, and now if we call levels again, you can see that now we have changed male, but not female. We can do the same thing without indexing if you want to change both. So we can feed in a vector of the 2 new names into that original levels call. And so if we run that and then you call levels on that sex vector, it's now the 2 retitled factor names. So what's essentially happening here is you're kind of like skipping a step, right? Is you have a function on the left side that's pulling out the levels of sex, and then R allows you to retitle essentially like the output of that function and edit the original factor. Okay, so factors can be a little confusing. We'll spend time with them throughout the quarter, but hopefully now after this video, you're at least you've encountered the words before and you're sort of ready to start doing a little more with lists, arrays, matrices, data frames, factors. We're moving beyond vector land. All right, thank you.